Hey guys, it's Mr. Morrow again with another edition of Morrow Teaches Online. Today we are learning about the last functions of the year. Yes, we did it, guys. We learned about linear, quadratic, absolute value, square root, cube root, piecewise. And here comes the last one, and it's probably one of the most important. It's called exponential functions. Okay? So here we go. So an exponential function is nonlinear, meaning it does not look like a line. And it's written like this. Let me get the pen ready. This is how they're written. The most important thing to notice is, first of all, in the word exponential, what word do you see? Yes, you see the word exponent. The exponent will always be a variable, usually an x, sometimes a t, but it could be anything. Again, exponential has an x as an exponent, but it could be any letter. Okay? And it's going to be multiplied by a constant factor or a constant ratio. So, if you remember when we did function tables with linear functions, it used to add or subtract by the same amount. Now, we're going to be multiplying by the same amount. And sometimes we call it dividing for some, but it's really multiplying, and I'll explain that later. But if you notice, we're multiplying by 2, multiplying by 2, multiplying by 2. Okay, so the common factor is 2, or the common ratio is 2. Okay, so right now we're trying to decide, is it linear or is it exponential? So if it's linear, that means it's going to be adding or subtracting by the same amount. If it's exponential, it's going to be multiplying. And we can call it division, even though it's not really division, but I'll explain that. So here's how you could approach this. So for A, you could say, hey, we're going down by 4, but wait a second. Is 4 minus 4 2? No. So that doesn't work. So instead, you could say we're dividing by 2. Divide by 2, divide by 2. But remember how I just said we're not really going to be dividing? So instead of dividing by 2, here's the way we would prefer. Do you agree that this is another way of writing divide by 2? When in doubt, put a 1 on top. Just say we're multiplying by a half. And if you're like, is that the same thing? Well, I'll ask you this. What's 10 divided by 2? 5. Okay, what's half of 10? 5. Do you see how dividing by 2 and multiplying by a half are the same thing? So again, this is the way we would prefer it. I mean, you could write divide 2 right now, but you're going to see in a few topics that it's going to be better if you don't. So, explain, you could say, this is pretty much explaining it. So, first of all, I actually never wrote what the answer was. So if we're multiplying, that's exponential. And showing your work would be, good enough. So, here we go. How do we get from 1 to 0? Subtract 1, subtract 1, subtract 1. Since we're adding or subtracting, that's linear. Okay. Now, for C, maybe you don't know how to get from 0.25 to 1. Well, whoever said you have to start from the beginning? How do you get from 1 to 4? Multiply by 4. How do you get from 4 to 16? Multiply by 4. How do you get from 16 to 24? Multiply by 4. Well, guess what this is? Just multiply by 4. Isn't there 4 quarters in a dollar? So there it is. So then that would prove it's exponential because we're multiplying. Okay? And then the last one on this, how do you get from 10 to 1? You can subtract 9, subtract 9, subtract 9, and what do you know? Subtract 9. Okay? And that would prove it's linear. Now going back to the exponential ones, let's say you didn't know what it was multiplying by. All you have to do is take the second number and divide it by the first one. What's 4 divided by 8? A half, or 0.5. What's 2 divided by 4? A half. What's 1 divided by 2? Guess what that is? A half. Same thing you could do here. Just take the second number divided by the first one. 4 divided by 1 is 4. 16 divided by 4 is 4. 64 divided by 16 is 4. 1 divided by 0.25 is 4. So if you notice, they're all 4. Okay? So, These are the four big ones we've learned this year: linear, absolute value, quadratic, and exponential. So when you graph this one, it's a U. What would that be? Quadratic. Remember, if you see the 2, it's a U. So that one is quadratic. This is the new one. If the X is an exponent, then it's exponential. The next one, if you graph this one, y equals, if you graph it, it's a line. It's linear. And I know this one's going to be a tough one, guys. If you see the absolute value bars, guess what that is? Absolute value. I know that one was tough. Okay, so now that we know about all the different graphs, let's now just focus on exponential. So it says evaluate the function when x is -2, when x is 0, and when x is half. So all you have to do is you're just going to have to use your calculator, and we'll do it together. So 2 times 9, but instead of x, what's the first x I'm going to use? -2. So we're going to go to our calculators, our handy-dandy calculators. Don't look at that. You'll do that next chapter. So 2 times 9. And remember, the exponent button is right above the division button. Right above division, you see that little arrow pointing up? That's a caret symbol. And then we type in -2. Now, that's not very pretty to write. How can I turn this into a fraction? Yes, you go to math for all our math needs. So it's right below the green button. You click math. The first thing that appears says frac. Press enter and enter again. So we're going to write 2 over 81. So 2 over 81. Okay, the next one, 2 times 9 to the next thing they want me to try is 0. Well, we should all know anything to the 0 is 1, and then what's 2 times 1? 2. But let me prove it to you using your calculator. 2 times 9 to the 0, and what do you know? You get 2. And then the last one is a half. 2 times 9 to the half. Okay, and that's going to give us 6 because a half is the same thing as square root of 9. But again, you don't need to guess. You can just prove it on your calculator. So 2 times 9 to the half. And there it is. You get 6. So again, all you have to do is just type those straight into your calculator. Okay, the next one. Now it says 1.5 times 2. The first one it wants me to try is -2. So when you type that in, you know what, why don't I just set them up for all of them? Okay, the next one was 1.5 times 2 to the 0. We'll find that out. And then the last one is 1.5 times 2 to the half. Okay, so here we go. Go to the calculator. 1.5 times 2 to the, first one was -2. So we're going to write 0.375. You could write that. If you wanted it into a fraction, press math, frac, enter. Or you could write 3/8. So 3/8. Okay, the next one. Did you ever know this? If you press second, enter, it will do the last thing you wrote. But if you press second, enter again, it will write what was even before that. So if you want, I mean, it's not that easy. If you press delete, D-E-L, you can change it now to a 0. I mean, if you want. Some of you might find it easier to just retype it. Okay, you get 1.5. And then the last one, if I recall, comes out really, really, really bad. 1.5 times 2 to the half. Ew. So we're going to round that. Let's round it to the nearest hundredth. 2.12. All right. So all you have to do is just type it in. So now here comes the graphs. Now, what I'm going to do is, because this is just going to confuse you guys more, cross this part off. That's just going to confuse you guys. All it was talking about was graph everything between -3 and 3, but then there's some certain things you have to do. So we're not going to go there. So now we're graphing. So again, if it says y equals, you know what to do. Go to your calculator. So y equals, go to y equals, type in 2. Now, some kids actually type this. No, that would be linear. The x needs to be an exponent. So get rid of that. Use the exponent button right above division, the caret, to the x. And you graph it. Now, these graphs are very interesting. They start off slow, and then they skyrocket. All right? So go to second table, Now we got to graph everything between -3 and 3. So they want their table between -3 and 3. So we're just going to copy this, okay? So here we go. You're going to copy that straight onto the table. 0.125, I'm sorry, it should be 0.25. Then, no, stop skipping. Come on, there we go. 0.5, 1, 2, 4, and 8. And again, it should match perfectly to that. So let's graph this. So 3, 8. Let's graph that. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Make a dot. 2, 4, 1, 2, 3, 4. 1, 2, 0, 1. Now, you remember how we've been telling you all year, if it's a decimal, don't graph it. Unfortunately, if you stop here, if you draw this, this would get you a wrong answer. You have to graph more because now it looks like it's going straight into the ground. So you can't stop there. You actually have to keep graphing these. But guys, I know you get nervous when you see decimals. It's not that bad. 0.5, that's half. So -1, just go halfway. Now, I know you're like 0.25. Well, think of it like a quarter. If you have 25 cents, is that closer to $1 or is that closer to $0? It's closer to $0. So just go a little bit lower. I have a question. Do you really think we're going to take a ruler and measure it out? No. For all I know, that's 0.3 or 0.1. All it has to be is slightly lower than the previous one. And then the next one will just be slightly lower. Now, the most important part of today's lesson is when you draw this, under no circumstance can you let this curve touch whatever line it's hovering over. So if you did this, let me demonstrate what not to do. If you did this, woo, you would see that on a quiz or a test. That curve cannot touch whatever line it's hovering over. Now, most of these hover over 0, but you're going to see ones where they don't. It can't touch that. There's an imaginary, well, first of all, I'll explain that in a second. Now, draw arrows, draw arrows. The arrowhead can touch the line, but the curve can't, okay? So if you're like, oh my God, but it's touching, the arrowhead can. And then don't forget to label y equals 2 to the x. I'm going to tell you a word that kind of sounds funny, but you're going to learn about it more in Algebra 2. There's an imaginary force field. Do you see how it started to curve over this imaginary force field? That imaginary force field, you ready for the word? It's called an asymptote. I know you're like, a what? Yes, it's called an asymptote. Not that you really need to know it for Algebra 1, but that's how you spell it. Asymptote. Yeah, it's a weird word to spell. It's like an imaginary force field. It tells me that that curve will never touch that line, ever. It could go on forever. It's never going to touch that line, even though I drew that really, really poorly. Okay? So it's called an asymptote. Not that you need to know that. And there's your graph. So that's what these look like. So this would be an example of exponential growth. Because remember how you read graphs from left to right? Do you see how it starts off slow and now it's growing? So that's why we call that exponential growth. So now let's look at the next one. So y equals a half to the x. So let's graph this. Y equals a half to the x. Now look at this one. Okay, now I know it looks like it's going to touch the line, and sometimes your calculator actually lies to you. If you go to the table, I don't think it will in this case, but sometimes it actually tells you you've hit 0. Nope, this is called scientific notation, don't worry about that. But sometimes it will tell you, hey, it's actually touching it. It's not. The calculator just lied to you. It's rounding it, and it's so small that it's actually rounding it to the wrong numbers. Okay, so it wants us to graph all this. Now, if you're looking at these numbers, and you're like, wait a second, I've seen these before. Yeah, if you notice, these are the exact same numbers we just drew, but if you notice, they're in reverse now. Okay. So now we're going to graph this. So now it's -3, 8, -2, 4, -1, 2, 0, 1. And remember, go half, go a little bit lower, go a little bit lower. Now, once when you get to the last dot, I would not go any further. Like some teachers tell you to go like this. I would not do that. You're being very, very risky. At the last dot, I would draw an arrow. Okay, and remember, don't let it touch that line. The curve, if it touches the line, it's a wrong answer now. Okay, we're very, very strict with that. And there's your answer. Okay, so if you notice, if you go from left to right, what's the graph doing now? It's what? Going up or down? It's going down. So this would be a form of exponential decay, which we'll talk about in the next video. But there's exponential growth, which means it goes up, and there's exponential decay, which means the graph goes down. Okay, the next graph. Now this one looks a little trickier because the exponent, and now it's asking for domain and range. So here we go. Go to y equals. I totally forgot what it said. What did it say? It said 4 to the x plus 3. So 4, exponent button. And again, if you have the new addition like most of us do, when you type in x plus 3, you should see it all in the exponent. So let's graph it. Okay, so this one skyrockets pretty fast. It's like a rocket ship that just takes off really, 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 really fast. So second table. Now, not a lot of these points are going to fit. So let's graph the ones that actually do. So let's start with, obviously, negative 116 is not going to fit. But let's start with negative 2, 4. So here we go. Negative 2, 4. So 1, 2, 3, 4. And then it was at negative 3, 1. And then it got really, really, really small fast. So if you notice now at negative 4, it's at 0.25. And then negative 5 is really, really, really close to 0. So let's just do that. So at negative 4, it was close to 0. And at negative 5, it was really, really. Remember, don't let it touch that line. So when you draw this, here's all you would need to draw. Just that, but don't let the curve touch the line. Draw arrows in both directions and label it. Now it's asking for domain and range. Domain is easy for these. Range you might have a little trouble with. So do you see arrows in both directions? Anytime there's a graph with arrows in both directions, your answer is going to be all real numbers because it's going on forever in both directions. So if it's going on forever in both directions, then it's just going to be all real numbers. Now the range is a little tricky. So what letter have we always used for range? Yes, we always use the letter Y. Now, look at your graph. You wouldn't actually draw this, but look at your graph. What's it curving over? What line? Do you guys see how it's curving over 0? So then that tells you what to do. And if you don't know that, just look at the table. You could just ask yourself, what numbers is it getting really, really close to? Now, I know you guys don't really know scientific notation, but before the negative 8, do you see how it's getting closer and closer and closer to 0? Personally, I think just looking at the graph, you can say, oh, yeah, it's curving over 0. So that tells me what number to draw. Now, this part gets a little confusing. A lot of kids think, oh, if it goes up, it's greater than. If it goes down, it's less than. It's not really that. So here's the border. Do you all see the border? Where do you see my graph? Is it above my border or is it below my border? Do you see how it's above it? So then you put a greater than sign. Now, let me just get rid of all this junk. So you put a greater than sign. You never, ever, ever put the line, ever. Because think about what the line means. It means it will equal 0. What did I just tell you? Will that curve ever touch 0? No, remember there's an asymptote. So again, it's an imaginary force field. It will never touch that. So you never, ever, ever put the line. And there's your answer. Okay, the next one. Here's an example where all the examples we've had have been curving at 0. I don't want you to think it always curves at 0. So here's an example where it won't. So let's type this one in. It's y equals 3 to the. Now this is where you guys could also make the mistake. If you type this, it's wrong. Look back at the question. Was the minus 2 in the exponent? No. So make sure that minus 2 is not in the exponent. So you see how there's a blinking arrow to the right? When you're done with the x, go to the right. Now that I'm down below again, now type minus 2. That's a very big mistake we see kids do. So 3 to the x, and then down below, minus 2. So you graph this. If you notice, it's not curving around 0 anymore. It looks like it's curving around negative 2. So go to second table. Let's try to find some points that actually work. And here's an example where I told you the calculator is actually going to lie to you. And I'll explain that in a little bit. Okay, 3 comma 25 doesn't fit, but 2 comma 7 does. So 1, 2, 3, 4, 5, 6, 7. Why don't I pick prettier colors? And then it was at 1, 1. Make them all blue. Okay, and then if we looked at the calculator, it was at 0, negative 1. All right, and then it's 0, negative. Okay, what do we have? So it was at 0, negative 1. And then if you notice, they keep getting closer and closer and closer to negative 2. So it's at negative 1.6. So if it was like $1.66, that's kind of close to 2. So it's going to be here, and then it's just going to keep getting closer. At that point, I actually probably would stop because I don't want to take a chance. So here we go. We're going to draw it slowly, and when you curve it, don't you dare let that curve hit the line. Draw arrows, and let's label it y equals 3 to the x minus 2. Now, if there's arrows in both directions, it's all real numbers. Now, the range, what letter do we use for range? Y. Now, what's it hovering over? What's it curving towards? It's curving towards this line. Well, what line is that? That's negative 2. Now, again, where do you see the graph? Is the graph above that line, or is the graph below that line? It's above it. So if it's above that line, you put greater than and don't put the line. Okay? And this is the last one. So let's do it. You're going to graph it. You're going to type in y equals negative 2 parentheses 4 to the x. Okay, you're going to graph it. Yeah, so this one's upside down. And what made it upside down? It was that negative in front, just like we've always been doing. So second table, a lot of ugly, ugly, ugly numbers. So let's start with 1, negative 8. So here we go. 1, negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then it was at 0, negative 2. And then it started getting really, really close to 0. Because then it was at 0.5, 0.125. And I know decimals are hard for us to draw. Just remember, 0.5 means half. So at negative, it's negative 1 point. Negative 0.5. So at negative 1, it's going to be halfway. And then it's just going to get closer and closer, but never touching that line. So draw it. And I know these are kind of hard to draw. Draw arrows. And then label y equals negative 2, 4 to the x. There's arrows in both directions, all real numbers. What letter do we use for range? Y. What was it curving near? It was curving at 0. But now, where do you see the graph? Is the graph above this line? Or is the graph below this line? Do you see how the graph is below the line? So since it's below the line, instead of writing greater than, you're going to write less than. Okay? And that's the lesson. Again, I really do miss you guys. I wish I could teach this stuff in person. And again, I look forward to making more videos for you guys. Miss you guys. Bye.